Again, may I repeat myself? Good morning. My name is Godwin, architect Thomas. I don't know that Dr. Kilantia. So far, I'm putting on a gable roof. Now I'm going to just take my measurement for my rafters to be exactly where my rafters is going to situate or sit. And after, I'm going to cut rafters. So my pitch of my roof is, I use a 312 in terms of height, which to every foot I go out, I go up 3 inches high, and that is the height of my ridge. Not too steep, not too dangerous for, people. So anyway, so far right now, I'm going to map. So then later on you'll see more of the demonstration when the rafters are in place.
All right, cool.
I was talking about the angle of the gable roof, which I said is a 312, which I explained earlier on. I go up 3 inches and I go out with 1 foot. So now I'm taking my roof rafter layout square to mark. So as I'm marking, this is the common rafter. We have hip and valley, so I'm using common. Common is just the simple, the short road. So it's a 312, I'm marking there. Bam. So I keep this, the pivot. This is the pivot of the square. So I hook it on the wood, then I look for the angle. Then when I find it, I mark. So now this is what they call a 312, which is the height of my ridge, cause that. Okay. So I'm going to cut. I'm going to cut. So I'm going to cut about 9 of them, same angle. And after when I cut 9 of them, I will go up and put them up. Then you will see.
So all will be cut at the same angle, correct?
Yes.
All right. And that angle again is
a 312.
A 312 angle. So all rafters will be cut at that angle.
Yes,
and guaranteed to fit.
If my ridge pole is not 100% plumb, I may have to do a little adjustment in the cut. But if the ridge pole is 100% plumb, I absolutely have no problem at all. So I'm catering for, because the wood has sometimes back and belly, and because of that, I may find myself have to do a little, adjustment with the cut. But that is minor. So I'm cutting. Okay, I was asked to explain how I managed to end up getting 312. Now, because of the width of the building, if a building is 20 feet wide, and I have to put a ridge pole is 10 feet center. So now, 10 feet center. So to every foot I go out this way, from the center, I go up 3 inches rise. I go up 2 feet, I go 6 inches rise. I go up 3 feet, I go 9 inches rise. So to every time you go out lengthway, your rise is free. It could be any dimension you want. It can be 4, 5, 6, whatever you choose to do, or what your elevation. So as I repeat again, this is the width of the building. So I go out 1 foot, I go up 3 inches. I go out 2 feet, I go up 6 inches. I go out 3 feet, I go up 9 inches. So I use this roofing square, which is 3. So I look for the 3 inches. The pivot is already the 12. Because there's nothing you can do about the pivot. That's what rotates the square. So once you put the pivot, you set the pivot, you look for the 3 inches that you say you rise, and then you look for it, and then you take it at the back of the wood. And once you have it at the back of the wood, that is what they call 312. Do you understand how I explain it? Again, repeat. To every foot you go out, you rise. So you go out 1 foot, 3 inches. Or it can be 4, it could be 5. So let's just say you use it. If I want to go up a like 6 inches, same thing. Basically same thing. 1 foot, 6 inches. 2 feet for the same dimension, because that roofing square have all the various measurements that you require for roofing. Most roof, I think, is the most steepest one people use is 12-12. So for example, if I have a 12-12, I have to rotate my square all the way like this. You can see the angle properly. See how steep it looks? So that's a very, very, very steep roof. Okay, with that said, I'm proceeding with act number 2.
Alright.
Basically, what I explained mean that you can build a roof from down. With practically down.
That means all your rafters can be cut
down. Everything, your ridge, your hip, your valley, everything. Because as I said, you that determine height by width. So, for example, me, I'm not saying I may not find any difficulties in the future in roofing, because I have some roof that have all kind of design and stuff like that. But basically, a roof can be practically built from where I stand in
from down on the ground.
Yeah, from where I stand in
and then you pass all the pieces out.
From the ridge pole. From the ridge pole, you send it up to the height that you want in terms of the pitch that you want. So, in practical sense, 4 frees is 12. So in the terms of 3 by 12, you'll call it a 1/4 inch pitch. 6 inches would be a 1/2 inch pitch. 9 inches would be 3/4 inch pitch. 12 inches would be a 1 inch pitch. So that 12 might be 12, the slope of 12 is a 1 inch pitch, and it's very steep and also dangerous.
Thanks for that explanation, Appetite. Now, all rafters are cut to fit and in place. We're just gonna place them.
Yeah, I'm putting up rafters now.
All rafters fit in perfectly, Appetite?
Yeah. Alright. Yeah, man. That's why I keep telling you, I take 3 inches for this and that. Like, you could have a little problem with the ring square. This is engineers. You know what I'm saying? That the ring square. So you can 3-4 inch screws and still have to use hurricane ties.
Alright.
So I can what do you call it? Hurricane resilient. As we go along, you all will be saying it so that you will
we are installing hurricane ties everywhere.
I repeat myself. My name is Godwin Thomas, small time contractor in St. Thomas, US Virgin Island. Now this is a roof that we are telling you about from the one that we started. We showed you about the fish tail log, the dead man and the ridge pole, etc. etc. This roof to resist against a category of whatever time hurricane. So now we have straps tie to our ridge, our rafter, so it holds 3 pieces of lumber at the same time. Then we have 2 hurricane ties in each corner. So from here to there is 4 hurricane ties in this corner. Also on all the rest of the rafter, the same design. Also at the bottom of the rafters are the same thing. Inside and outside has hurricane time. As you can see, hurricane ties, and our facer board is alright. We screw the facer board onto the rafters. So when we talk about hurricane resilient, this is one of the roofs that could withstand a category of, tell somebody this is resilient. So we're at the stage of this work. I give thanks to my fellow co-employees to assisting us, me and all of us together to do this kind of roof. So if you need a roof, get done or to get done, you can contact my number. As I said, nothing is too big, nothing is too small.
What's the number?
The number is 227-5299. I can take a structure from nothing to build it to something. So in closing, this is what we call hurricane resilient roof. As you can see, if you see very carefully how much ties it have. So each rafter on the opposite side, as I say, has 4 hurricane ties. 2 on the left and 2 on the right, and plus a strap over. So what does that tell you? Everything is bind together. Also down at the plate, as you can see, we have the plate is bolted down on some round column to some plate that step up. Then we have hurricane ties inside and outside. So for this roof to go, the whole entire roof, and with the weight, it is very difficult because everything is connected, so it's very difficult to believe. What I say again, God is more powerful than mankind. With that enclosed, that's what we call hurricane resilient roofing.
Thank you, Appetite.
Thank you, Appetite. Thank you.
Co-employee, this one on the fire in there. And
Hard worker.
And the one that you cannot see behind the scene,
Kakarat.
is the legal advisor.
Kakarat.
Alright, that's good.
Alright.
And the blocking. As you can see, the ties them from the inside, and we have blocking. The blocking binds again. It binds all the lumbers together. So as I'm saying, the roof is very heavy to be lifted. So as we do again, this is what we call hurricane resilient.
Oui. Non, Magni.